be in this balloon experiment, we are going to learn how to make the world's first hovering balloons. Okay, maybe not the world's first, but we're going to make hovering balloons. We want to make them fly without pushes, but see, it came down again. See, you have to push it, but then it will come down. So we are going to find a solution without even pushing it, and it will stay in the air. Let's first try this fan we have here. Let's just bring its plug over here, and we're going to take it here. And we are going to push to this turn. We're going to take one of our blue balloons, and we are going to put it straight here. Okay, everybody, we're just going to get this party started. So let's get started. Yes. Wow, the balloons are flying, but they came down again. What solution can we use to make this thing better? Another solution I have involves pillows. We are going to use these pillows to make a wall type thing where, so we are going to put this in and put these things like a wall. Let's see if that can work. Okay. We don't want to be that fancy. We're just doing a fun experiment, so that's why they don't have to be too fancy. I just got these pillows. I found them. Now let's see. Now it's not even lifting up for a second. So let's retry. We're not going to use this one fan, but we're going to use a different fan this time. We are going to use a fan different shape. Now you're probably wondering, what is a shape going to do? Let's see and find out what happens. Let's make space for the thing. Now, like that thing that just happened, we're not going to directly put the balloons in that pillow, because the pillow, we don't know. Let's first try like how we started with the white one. I'm going to put in this, put our move over. There it goes. But it keeps on going. Let me explain how it does this. Basically, the human hand can go through. But if you actually try this experiment, what you can feel is the air. You can feel it even here. If you put your hand simply just there, you can feel at least some air, right? If you can, well, here's what is happening. The fan, the electricity from the power plant travels through this wire into the fan and spinning motor, which then is surrounded to gears, which then blades, which then produces air super fast, and then it throws the balloon. The air is, but in this fan the difference is, this is a circle. So like, maybe you have seen a tornado. Well, they go like that. So same, this is a circle, that's a triangle. And if even this triangle could produce a tornado, it would be weak. And this tornado is like sucking it around, except it doesn't want to a pattern. So now we know, but it lasts at least longer. Let's repeat what just happened in the video. Wow, even two balloons can be supported. Balloon fight! And after all, it does look like a balloon fight. You can use this technique to make your very first game, a balloon fight. See, these two balloons are punching each other like they did. It's going under for an attack, and it goes up. And now, why is this going higher always? This thing, if it's ever going to go high, it's going to go high rarely. Let's take our friend this balloon now. Check it out. If you compare compare it to this, it has more mass. I mean, maybe balloons don't contain, but it has more air. You can see that's more bigger because it contains more air. And now, the more air, and I mean, this makes no sense, but you're probably thinking the heavier one will go down. So the less, like a boat will go down if it's too heavy. Well, it's actually the opposite. If it's not heavy enough, it won't go that high. See, that one just went, but it's going to go down sometime. See, it just went down. The bigger balloon is all at least up for a bit longer. See, it went down again. Now let's repeat what just happened to our friends. We are just going to repeat what just happened right here. Okay, well, what happens if we now put so much air? Let's see what happens. We are going to do this, and we're going to see what happens. What if you put two things? Does this thing go higher? Now let's just repeat. See, this thing is going even lower than it is going on this. Now, see, but this may be a powerfuler fan than this, but this is a different shape and this is a different shape. Here, I'll show you. Maybe a bit dark too, but really, it's just a fan that's over it. See, it's a triangle with curved sides. Okay, maybe it's lasting longer this time, but it's going to go out soon. So now what basically just happened is when we first took this pan and plugged it in and all and put one of these balloons, no matter what size we put in, it didn't form a tornado. What I mean, like the water tornadoes you can create, like you mix it. Here's an experiment you can try. Take a bucket of water and mix it. Well, the same thing happened except with air. But this thing wasn't getting produced from this pan. It couldn't produce it. Why? Because of its own shape. Now you may have never discovered, but shapes can sometimes matter. So basically this shape, and this thing on the other hand created the tornado feature, which would not let it slip out because of the walls. Only like if you have enough force you can break through the walls. That's the difference and why this fan is more efficient in this than it is in air. So forget about the most air it's producing. Just produce and think about the shape. Bye guys, thank you for watching and please subscribe. Bye. I'm just